Hello again, I'm John Joshua Biloño, here to perform experiment 4 regarding the interrupt on change for 8-bit microcontrollers. So, for this one, we're gonna have and open up a new project. Choose PIC 16F18875 as our chip with the XC8 compiler. Then we're gonna browse to the folder experiment 4 and name it as XP4. Now that we have it in the way, we're gonna go on the tools and embed on the MCC. We'll select MCC Classic and click Finish. So we'll go ahead here and select port RA4 as our output and port RB4 as our input. We're gonna change the name of RA4 to D2 LED. D2 LED. And it is digital output, where our RB4 would be named as switch 1 with the IOC or the interrupt on change at negative edge. Okay, after that, we'll go ahead to our interrupt module, where we can see that the pin module is enabled. And in our system module, we have the same set of oscillator, internal clock divider with enabled loop voltage programming. With that, click generate, and we can see here that we have our generation complete. So let's go now to our files in this current project, main C, and then we're looking for the enable of the interrupts here, and then we just leave the while loop blank here because the interrupt will be automatically be done on the other file, which would be the under the MCC generated files pinmanager.c. So here in pinmanager.c, we're looking for the default interrupt. So looking for the default interrupt, so here we can see our default interrupt. So in here, we'll type the code D2 LED toggle. This would toggle our LED. Now, let's go ahead and click build. There we can see our build is successful. Now we'll go ahead to our IPE, which is already connected to the PKit tree, and browse for the hex file, which would be under the experiment 4, this default production, and this would be our hex file. We'll go ahead and program it. Now program is completed, we can now disconnect and go to our circuit. However, before we proceed, there were actually some changes that I'd like to execute here. So the first change that I did was having a delay of 50 milliseconds before toggling the LED. The reason for this is that when the switch is triggered, sometimes due to mechanical properties, the switch bounces back. So it triggers for a second time even though you only pressed it once. So this is called switch bouncing. So to prevent switch bouncing from happening as often as we could, I first delayed the the toggling for 50 milliseconds so that within 50 milliseconds, if ever the switch bounces back, it won't trigger. So that only the first time you press the button, that's the only time that the the program or the chip will recognize the change in the state of the input. So after that, I've also had check the weak pull up for our switch. This is to mitigate any um, losses on the voltage side of things because my LEDs are quite weak. So now that we have this, let's just build this code. Okay, so now the build is successful. Let's reload the hex file automatically. And since the picket tree is already in, let's program it. The programming is now complete. I'll disconnect the picket tree and let's head over to our circuit. Okay, so here is the network. So we've programmed the D2 LED as RA4, meaning it is the fourth quadrant LED here. So if I press from the off state, if I press this, theoretically it should turn on because the switch has changed a state. It turned on. So if I press it again, it will turn off. And on again, and off again. So our code is a success. Moving on to the next part of the experiment. The next part would be just adjusting the code such that it would toggle on multiple LEDs. In my case, let's go ahead with the LED 1, 2, 3, and 4 setup just like last time. So going on to our pin manager grid view, we'll have multiple outputs on RA1, 2, 3, and 4. And on our pin module, we'll have renamed this as LED4, here as LED3, here as LED2, and here as LED1. All digital outputs. And then we're gonna generate it. Okay, so we have merged the code. I simply want to retain that. Change this. Change this. What are the other changes? We're gonna keep that because that is part of our code and nothing more. Okay, so we'll move ahead with that, but this time we have here LED 1 to LED 4 to toggle. So we just copy and paste this. And replace it with 2, 3, and 4. Now that we have edited it, we can now build it. Okay, now that the build is successful, we can now automatically reload and we'll connect our picket tree and wait for it to be recognized and connect. Now that it is found, we're just going to have and program it. Program is complete. We'll disconnect the picket tree and head over to our circuit once again. Okay, so here is our circuit. So this time all should be toggling on and off at the same time. So we press, oh, so sorry, the source isn't on yet. Wait. Okay, so we can now press this. It's on, it's off, but the other two are not responding because I have taken away their ground. Wait, I'll restore their ground. Okay, so just like the last experiment, we're gonna trigger this on, and on, and as you can see, this LED right here isn't on. That's because that's the only LED that is not connected to the ground. The reason for that is that when it is connected to the ground, the voltage across the diodes get decreased, so they do not light up as much. So they are so dim when they're lit up. So by sacrificing one LED, we can see that all the LEDs, the other LEDs light up. On, then we can turn it off, on, off. So in conclusion, the interrupt on change just means that when the input changes state, the output will perform the interrupt. So that's all for this experiment for interrupt on change.